viewers and subscribers, welcome back to my channel. Welcome back to another video. And in today's video, I'm going to talk to you about how to go about constructing your foundation footing. So your foundation footing is the most integral part of your structure. A matter of fact, it is the most important part of any structure. Your foundation footing is chiefly responsible to carry the weight of the building. And if the foundation footing is not designed properly or is not constructed properly, then your building or your structure is subjected to failure. So you would want to construct your foundation footing in a way that it is safe to carry the weight of the building without stressing the soil beneath the footing. So I'm going to shed some more light on this topic and give you more clarity in terms of how to go about constructing your footing in such a way that it can perform and carry out its duty to protect the building and to instill that the structural integrity of your structure where foundation is concerned is maintained. So stay tuned for this video. So here, the drawings on your right of my screen is what is showing a typical cross section of your foundation footing or your footing for your foundation, same thing. So the first thing you should observe when you're talking about your foundation is the depth of your foundation. So in this case, it is 3 feet minimum. And notice what I've said, 3 feet minimum. Therefore, it can be more than 3 feet, but it should not be less than 3 feet. Now, when you're doing a commercial building, a building that is going to have a lot of weight, a building that is heavy, ideally, you should get a geotechnical engineer involved to determine your depth of footing. But because a typical residential building is considered a lightweight building, a building a floor or 2 floor is considered a lightweight building. But if you're going upwards of two floors, then I would recommend that you should have a geotechnical report to detect or to come up with the depth of your foundation. So your geotechnical engineer will visit your site, do his core boring, and take samples of the soil, take it back to the lab, carry out the bearing capacity test, and tell you the weight that soil can carry, and also the depth and size and type of your foundation. But in this case, a typical 1 floor, 2 floor building is considered a lightweight building. So 3 feet, 4 feet is good enough if you're talking about a good soil. Now, if you're building on a weak soil, then obviously you have to employ a type of footing that can spread the load and can carry the weight of the structure safely, or you can excavate to a depth that surpasses that weak soil to anchor your footing. And this should be guided by a geotechnical engineer. So what you're looking at now is the foundation footing. So I've talked to you about the depth of your foundation, 3 feet minimum, 4 feet. And also what I want to point out too, that if you're excavating your footing, your foundation, and if you come up on weak soil that is loose, or mud, or peats, you should over excavate. And this can cost more because, obviously you're going to pay your contractor or your builder to dig the foundation at a specific depth and a specific width. so that they can come up with a rate so you can pay them for that volumes. But if you're going to over excavate, then you're going to go deeper than what is on the drawing. But it is very pertinent to know that if you're excavating your footing and you should come up on soil that is unsuitable, you should over excavate so that you can place your footing on suitable soil with adequate bearing capacity. Now, if you observe this footing in greater detail, you will observe that the width of this footing here is 2 feet in width and 9 inches in thickness. So let me give you a little background of how I get my footing to be 2 feet in width. Now, for design purposes, your width of your footing should be 3 times the thickness of your wall. And that is why more than often you see your footing 1 foot 6 inches in width or 18 inches, because your thickness of your wall is 6 inches and 3 times 6 inches is 18 inches. And that's how most of the time you will see that your footing have a width of 18 inches. But that 18 inches is minimum. It can be more than 18 inches, but it should not be less than 18 inches. So that is a starting point where design of a footing is concerned. We times the thickness of the wall by 3 to come up with the width of the footing. Now, if you observe, this footing is 2 feet wide, and the reason I have my footing to be 2 feet wide, when I'm doing a multi-story building, a 2-floor building, I like to spread my footing a little bit wider. The wider you spread your footing is the more stable your footing, because you have to remember from the formula, stress equal to force over area. So if the force remains the same and you increase the area, then you're going to have less stress. And if you reduce the area and your force remains the same or the weight remains the same, you're going to have more stress. So the wider your footing, the less the stress, and the less the stress of the soil beneath the footing, because you do not want to overstress the soil beneath your footing, because if that is the case, you can end up with collapse, or otherwise known what we call shear failure. I think I've done a video previously where I elaborate on that. If you go back to one of my previous videos on foundation design, you will see where I mentioned something in that regard. So that deals with the width of your footing. Now your thickness of your footing, again, your thickness of your footing from a design standpoint is 1.5 times the thickness of your wall. So those are minimum. And if you notice, this is 9 inches. So 1.5 times 6 inches, that is 9 inches. The reason it is important to have adequate thickness for your footing is to resist against what is called punching shear. So if the thickness of your footing is not to a certain dimension, what you have the weight of the wall punching through your footing. And that is why at a minimum we times the thickness of your wall by a 1.5 to come up with our thickness of the footing. And that's minimum. Oftentimes it is more if you're doing bridge or a heavy structure that is going to have a lot of weight bearing down on the footing. You want your footing to surpass the 1.5 times the thickness of your wall. But for starters, at a starting point, your thickness of your footing should be 1.5 times the thickness of your wall to resist against punching shear. I just want to put that out there for clarity. Now, another important aspect of your footing that I want to highlight is your concrete cover, right? So what the code, I think what the ACI code has mentioned, I don't remember the section now, but if you're having a structure below ground, the minimum cover for your reinforcement is 3 inches, and above ground is going to be 2 inches. But in this case, I have 3 inches for my cover for my reinforcement at the bottom, and I have 2 inches at the side. But ideally, this is a residential building, and based upon my understanding, I do not have to be that rigid with the thickness, but 2 inches is still adequate. I just want to point out another importance for your concrete cover, and your concrete cover is really there to protect the rebar from corrosion, to protect the rebar from corrosive chemicals that are in the soil, and also to protect the rebar from moisture that is going to cause the bar to corrode. So if your land or your site is in an area where the water table is high, you're going to get moisture to go into your footing. As you know already, concrete is very porous, and water can pass through very easily and get to your rebar. So your cover is there to protect your rebar from corrosion, and if your rebar is corroded, then it's going to disintegrate, and as a result lose the effectiveness to carry the load. In some of my projects here in the States, what we use is a epoxy rebar. So we paint the rebar is painted with a certain color, a certain solvent, to protect it from that corrosive environment that can cause your rebar to corrode. So let me show you what epoxy rebar look like. So this is an epoxy rebar. So as you can see, it is painted with this green solvent to protect the rebars from the corrosive and moisture environment that is going to cause your rebar to be subjected to corrosion. I just want to point that out, okay? Another important aspect of your footing too is that, and I've seen it on many sites, that when the builder, contractor, or the workman, or the laborer have excavated your trench, they just put the rebar flush, or the footing flush on the ground. No, that is not recommended, especially if your soil is of a certain nature, right? With corrosion and potential hydrogen and chemicals and all that. First thing you should do when you excavate your footing to the required depth is to cast what we call a blinding layer of concrete. So this blinding layer of concrete can be within the range of 1 to 2 inches. And this concrete does not have to be strong, and it does not have to, and the mix does not have to be proportional. You just want to provide a cover on the natural ground for your concrete footing to be placed. And that is paramount. That is important, to cast or pour concrete an inch or 2 thick to cover your ground as a blinding layer. So you see here on my footing, I call this out 25 millimeter, 1 inch thick blinding layer of Class C concrete. So that is important. Another aspect of the footing that I want to highlight to you is the backfill. So oftentimes when you excavate your foundation, you're not, I have seen it where people use that same excavated material to backfill the footing. That is not acceptable. You should backfill your footing with the same material that you're going to use to fill the area above the ground. So you can use marl in some instances. Some people use marl, but my best material, the best material in my interpretation to use is river shingle, because river shingle is a free draining material and it does not absorb water. So you want to backfill your footing with free draining material and not the excavated dirt or soil that you have excavated from your footing. And the reason for that is that you want to have that backfill material as a free draining material, so it does not absorb water and as a result increase the weight of the soil on your footing. So if this is an unsuitable soil here, when water come into contact with this soil here, it's going to become saturated and it's going to become heavy, right? And it is going to cause the base of your footing here to carry more weight than what it is designed to carry. So you want the material to drain away your water as quickly as possible so that it doesn't build up the stress on top of the footing and as a result put more weight on the soil beneath the footing. So that is critical. So always cart away your excavated material and backfill your wall, your footing with suitable free draining material. And another important aspect of this too that I want to point out, you should always consolidate your fill and consolidate your backfill material. In this instance, I determined that it should backfill, it should be compacted every 8 inches, because when you just throw down the material like that and it is not compacted, when you put the floor slab on top of that uncompacted material, then you're going to have settlements. The material is going to move down because of the weight of the slab on top of it, and then what is going to result in cracks in your top of your concrete, or cracks start to show up on your tiles, and tiles are very expensive and you do not want to put down your lovely tiles and then soon thereafter you have to replace tiles that are cracked due to settlement issues in your consolidated fill. So that is an important part to observe as well. Another part of this foundation that I want to highlight too, is the placement of your rebars. I've seen where people put down the longitudinal bar first and the short bar here, this bar here, they put on top. So that is not the way it's supposed to be. This bar here is supposed to be placed down first and the longitudinal bar placed on top in the long direction. So this bar here, the bar in the cross section here, plays a critical role. That is the bar that is responsible to carry the weight of the structure or to resist against the moments that the soil is going to have on the base of the footing. So that this crossbar here, this transverse bar here, is very critical. The one on top is what is known as the distribution bar, or your temperature or shrinkage bar. That is responsible to distribute the load, and this crossbar here is responsible to carry the load. And you have to maintain that, because if you flip it and put the longitudinal bar at the bottom, you're going to have problems, the moments that the soil is going to push against the base of the footing is going to cause your footing to be unstable. So that is paramount. A next aspect of your footing detail, which I want to highlight too, is that when you're putting on your concrete slab, you should ensure to put in your BRC mesh. I've seen a lot of sites where they just put down the concrete without the BRC mesh. Now, the importance of the BRC mesh is that, as you know already, concrete is weak in tension and strong in compression. So when the weight on top of the floor is going to be impacted by the concrete, it's going to be subjected to cracking at the base here, just as in a beam. So you want to put the BRC mesh here to increase the tensile rigidity of your concrete so that your concrete can remain stable. So that is it. I think I have touched on some good points here as it relates to your footing. And in recapping, as I've said to you before at the beginning of this video, is that your foundation footing is the most critical part in your building. It is responsible to carry the weight of the structure. It's just like a human body, right? If your feet or your foot is not strong enough to carry your weight of your body, then you can't walk, you can't stand, right? So your footing has to be strong and it has to be built properly so that it can carry out its full function. So that is it for this video. I hope you find the video informative. If you have any question and if I have left out anything and you want clarity about anything, you can shoot me a comment. As in the case with my other video, if you have any problems and you highlight something, you want clarity, just let me know in the comment section. So I see you, catch you in another video. Thank you.